Let's have a look at this little teaser. Okay, so we have to sum between r equals 0 and 49 minus 1 to the r, 100cr, which is the combination. Now, minus 1 to the r, basically all that means is that it's going to be an alternating series between minus and plus. But let's expand it anyway. So let's put in r equals 0. So basically this is the expansion of what it is. So it equals minus 1 to the power of 0, 100c0. Let's put in r equals 0 into here. Add minus 1 to the 1, 100c1. Add minus 1 squared, 100c2. Add minus 1 to the 49. This is the last term, 100c49. Okay, and let's call that anyway. Let's call that s, because that's what we want to find. So let's just simplify it slightly. Okay, so minus 1 to the 0 is 1. So that makes 100c0. Minus 1 to the 1 is minus. So that's minus 100c1. Add 100c2. Minus 100c3, etc., 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 all the way to the end one, which is minus 100c49. So that's what s is. That's what we want to find. Okay, now how do we find that? What we have to do is we need to look at the expansion of 1 minus x to the power of 100. And if we look at this, what we will get is equal to 100c0 add 100c1 times minus x, add 100c2 times minus x squared. This is just the basic binomial expansion. Add 100c99 minus x to the 99. Add the last term, 100c100 minus x to the power of 100. Now clearly that's not exactly what we're looking for, so we need to do some amendments. Now the first thing we do, it's a lovely little trick this, let's put x equal to 1. So we get 1 minus 1 to the 100 equals 100c0 add, well 100c1 times minus 1 is basically minus 100c1, and then add here minus 1 squared, which is this one here, is plus, that's 100c2. Okay, blah, 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 blah. Okay, now minus 100c49. We're halfway through. Now I'm just going to, oops, sorry, excuse me, didn't mean to do that. Now I'm just going to write this bit slightly differently here. I'm going to write add 100c50. Now all I'm doing is I am expanding, is I'm putting x equal to 1 in this thing here, and then we're going to carry on down here, minus, and you'll see why I'm doing this in a minute, 100c51, add 100c98, minus 100c99, add 100c100, which is basically the last term of the expansion of 1 minus x here. Okay, so let's have a little bit more of a look at this here. Using nCr equals nc n minus r, we can now simplify this, because obviously 100c100 using this formula here is the same as 100c0, 100c99 is the same as 100c1, 100c98 is the same as 100c2, etc., etc., and of course 1 minus 1 is 0, so 0 to the power of 100 is 0. So let's simplify this here as 0 equals 100c0 minus 100c1, add 100c2, minus 100c49, and we'll keep this written in this way, add 100c50, and then we'll go here, will be minus 100c49, which is this term using this formula, has gone into this term here, and then here this will again be 100c0 minus 100c1, add 100c2, blah, 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 blah. Okay, now what we can do now is we can see that this here is identical to this here, and furthermore it is identical to s, which is what we are trying to find. So all we can do is we can now plug s into here, and we get 0 equals s add 100c50 add s, i.e. 2s equals minus 100c50. So s equals minus a half 100c50, and so therefore that is our answer. Now we could simplify this a tiny little bit using n plus 1c r plus 1 equals n plus 1 over r plus 1 nCr. We could actually rewrite that as, we could rewrite 100c50 as, we could rewrite it as 100 over 50, 99c49. And why would we want to do that? Well, that means that we can then put that in there, and the s equals minus a half times 100 over 50 times 99c49, which equals minus 99c49. So in actual fact, the sum that we are asked for, you could either write it, it depends, often these are multiple choice questions, and sometimes they will put that one in to try and trick you. So s either equals minus a half 100c50, or, well, and it equals minus 99c49. So they're the two sums. Okay, what is quite cool about this is that the fact that n here is 100 makes it can be generalised. So in actual fact, we can generalise this solution here to be that the sum of n over 2 minus 1 to r equals 0 of minus 1 to the r nCr, which is just a generalisation of the actual question, equals minus a half nc n over 2, which equals minus n minus 1 c n over 2 minus 1. And if we were to put n equals 100 in here, we would get that the answer to the question equals that and that. And what's even cooler, for those who are still watching, if we, and I'll tell you, let's just go on the other page, next page here. If we were to just draw Pascal's triangle, 1 3 3 1 1 4 6 4 1 1 5 10 10 5 1. Let's just draw a couple more lines here. 1 6 15 20. This is Pascal's triangle, and bear with me, I'm just going to write it, and then you'll see something quite cool in a minute. Well, it depends on you what your definition of cool is, quite frankly. Some people won't think this is cool, but I do, and I think a few GREST Academy subscribers might also think it's cool. So let's just do this last one here. 56 70 56 28 8 and 1. Okay, so this one here is n equals 8, this is n equals 7, blah blah blah, all the way down to here, which is n equals 1. Now what is cool is that what this sum here is actually saying, and by the way, it only works for even n, I don't know if I mentioned that earlier in the video, but what this sum is actually saying in practical terms is that this, take away this, add this, take away this, so which would be would be minus 35, equals minus a half times that, which is, in this case, 8c4. So that, take away that, add that, take away that, equals minus a half of 8c4, which also equals minus 7c3, which is that one. So in actual fact, and it works for n equals 8, it works for n equals 6, n equals 4, any even number, n equals 2. You'll find that when you go this number, take away that number, add that number, take away that number, you get minus half of that number, which also equals minus that number, which I think is quite cool anyway. Anybody who also thinks this is cool, feel free to subscribe to the GREST Academy YouTube channel, and anyone who doesn't, feel free not to. Thank you very much.